In this presentation, we will review the procedure for completing the square. Your goal is to transform the standard form quadratic equation to vertex form to easily locate the vertex. This is a procedure you reviewed in Algebra 2. If you notice, when we do this transformation, the vertex point is HK. Please note the opposite sign for H in determining the vertex point. You may wonder why this is called completing the square. Prior to the development of algebra, quadratic equations were solved using a geometric technique. The next slide will step us through this geometric process of completing the square that was used in ancient times. Let's assume we have a square, x squared, to which we add b. The total area of the blue and the brown areas would be x squared plus bx. We're now going to, through a process of geometric steps, transform this rectangle into a square. We'll divide b into half and add it to this portion of the blue square. As I do the steps, you see that the area of the two brown halves is b over 2x. To complete the square, we need to add in this small piece here, which is b over 2 squared. The total area now of our square is x plus b over 2 times x plus b over 2, and we end up with x plus b over 2 square. We have now completed the square, and this is the geometric process of performing this operation. Algebraically, the area of the square can be represented by the left-hand side or the right-hand side. Your goal is to rewrite x squared plus bx as the square of a binomial where x squared plus bx plus c equals a binomial squared. We have to find c. To find c, we'll use the geometric method that was displayed on the previous slide, where we have b, we have it, and then square it. Please keep that in mind. What follows is the procedure for doing this algebraically. Let's use our example y equals x squared minus 4x minus 13. To begin, you want the equation written with only the x terms on one side. We'll then have the b term and then square this term. We'll now add the squared term to both sides of the equation to keep it in balance. The right-hand side here is now a perfect square trinomial and can be rewritten as such, where negative 4 over 2 equals negative 2. We will now take the remaining terms on the left-hand side and we will gather them and move them to the right-hand side. So we've added 13 plus negative 2 over 2 squared to obtain 17. Move it to the right-hand side, it's negative 17. We now have our quadratic in vertex form. Here's another example, except the a term is now 3 instead of 1. We have to account for this as we complete the square for this problem. The best process for doing this is to move the negative 9 to the left-hand side, divide by 3. We can now complete the square on the right-hand side. We'll do the same process of having b, square it, adding it to both sides. The right-hand side now becomes a perfect trinomial square. We now sum our terms on the left-hand side. Bring that over to the right-hand side. We'll now have y over 3, multiply both sides by 3 to obtain the vertex form. Here's a practice problem. I would pause the video and try to do this on your own. Your solution should look as follows.